there. Let's talk about this problem here. So, the mad scientist had one solution that is 30% acid and another that is 18% acid. How much of each should he use to get 300 liters of a solution that is 21% acid? So we are given some facts here that's telling me that there's definitely a mixture problem here. So here's one of the methods that we use for a mixture problem. We have pretty much a chart like this, and we're given 3 pieces of data, so it's a 3x3 chart. Just like that. And we know that we have one solution that's 30% acid and another that is 18% acid. And the overall total should be, let's just write total. So, the top part here, we should know at first how much amount of acid for each solution. Next should be the percent. Percent of the acid. And the final is just the mix. Let's get started filling in data. For 30% here, 30%, we don't exactly know how much of 30% we have. So let's just call it X for now. And let's go down. How much of 18% acid are we given? Well, we don't know either. But we do know that the total should be 300. And if we want to add these together, if we just want to make a temporary name, let's just call this 300 minus X. Because we just need to know how much of 30% we have, but we don't really need to know the other values. So we're just going to call it 300 minus X so that when we write the equation, it doesn't matter what X is. At the end, the x's still cancel each other out, and we'll have 300 equals 300. Alright, so let's go to the next column. And for this column right here, all we did was just add them to find the total, 300 liters. For the next column, we're trying to find the percent of acid. That's pretty easy because they already tell you the percent, because 30% acid and 18% acid. So that's pretty easy. 18%. If we write this in a decimal form, it'd be 30%. So let's say 0.3 and 18% is 0.18. You add these together to get 0.21, which is just like what we're solving for. The final one, you have to multiply the two rows together. So we would multiply X times 0.3 to find the mixture of 30% acid. So 0.3 times X would be 0.3X. 0.18 times 300 minus 18 would be 0.18. 300 minus X. And the last one, 300 times 0.21 is 63. Now we would have to add this column together, and we'd get 0.3x plus 0.18, 300 minus x equals 63. What we have to do is we have to distribute this right here, and we would get 0.3x plus 54 minus 0.18x equals 63. At first you may think, well, 0.18x minus 0.3x is negative 0.15x. Actually, that's wrong, because if you remember correctly from the problem, 0.3 is actually 0.30. We just have to add this 0 here. So it's the same thing. The other one, 0.03, would look like this, but since it's like this, we can write it as 0.30, and it's actually greater. So let's continue on. So, 0.30x plus 54 minus 0.18x equals 63. We can combine like terms, and we would get 0.12x equals other side 9. And that would be x equals, if we multiply both sides by 100, 12x equals 900. X equals 75. And that's how much x we'd have. So the amount of 30% liquid is 75. So 30% acid would be 75 liters. And let's just plug it in for 18. 30 minus 75 is 225 liters. And if you add them together, we have at the end 300 liters, so it all makes sense. That is the final answer right here. So let's recap. So what we did first is we made a variable in x, which is for the 30% of acid, and we found out how much acid there was and multiplied the two rows together to get times dot 3x. Same thing for this, except this one was in terms of the inverse of x. So whatever x is, it's just basically 300 minus it, and times it by 0.18, and we got this. And same thing for the last one. And what we did is we added this column together to find the eventual result of 30% acid, which is our result right here. Thank you for watching, and if you have any questions, I'll be happy to answer them.